Welcome back to this video. Today I'm going to explain you Anova test in two way. Before that I have explained the Anova in one way and I have uploaded video for this. So you can check out that video also for one way Anova. So let's start. A farmer applied three types of fertilizer on four separate plots. The figure on yield per acre are tabulated below. Analyze the variance of this data that plot and fertilizer are not different. So here is a table given and the fertilizer and plots are given that yield these numbers of data is given that these are yields due to nitrogen. These are the fertilizers are here: nitrogen, potash and phosphates, and the plots are given also A, B, C, D. Then how we recognize that this is the two-way ANOVA? The question that this is two-way ANOVA or one-way ANOVA. So we can know about the two-way ANOVA that by considering the table that it has two types of variables, that is plots and fertilizers. In one way ANOVA there is only one type of variable, so that whether it is ABCD or nitrogen, potash, phosphate. In one way ANOVA only one type of variable is given. So here is two type of variable given, so we consider two way ANOVA. And also that I want to explain you, this is two way ANOVA without replicates. What is replicates? Here is only one observation for the plot A and nitrogen fertilizer. If there is more than one observation, then we can say this is the two-way ANOVA with replicates. So this is without replicates, so it is for one observation. So in the next video, we will do this with replicates. Now this is the question without the replicates two-way ANOVA. So how can we solve this? First of all, the first step will be, the null hypothesis will be the yield due to fertilizers or plots are not different. There is no effects of any variable on each other. That there is no effect of fertilizer on plots. There is no effect on plots on fertilizer, and there is no effect of plots and fertilizer on yield. So the alternate hypothesis will be the yield due to fertilizer or plots are different. We take the alternate hypothesis opposite of null hypothesis. So and also that if the alpha is not given, the significant level of significance, so we will take alpha as 0.05, say. Then we compute sum of squares. For the sum of squares, we draw the table for this calculation. Here is the table for calculation: fertilizer yield A, B, C, D, nitrogen, potash, phosphate. And here I have taken the total of these rows, 3 rows, and also the taken columns total. That is, I call this Tj and I call this total Ti, and the grand total will be T. Okay. Then the next step will be, we compute the computation of SS, that is sum of square, correction. First of all, we will find correction factor. Then we will find the other SS, sum of squares of total rows and columns, and error also. So C, we will denote correction factor as C is equals to T square divided by N. What is N? N is the number of observation given in the table. So we can count them and write it here. And T is the grand total, 84 square divided by 12. So the next SS between rows. So we will find sum of squares of rows, that is fertilizers. SS R is equals to summation Ti square divided by Ni minus C. What is Ni? This is a number of observation in each row. So Ti, what is Ti? Ti square, we take square of each row, that is 24 square divided by 4 plus 28 square divided by 4 plus 32 square divided by 4 minus C. What is C? 84 square divided by 12. If we calculate the values, then we get 8. Then likewise we will find sum of square between the column, that is plots. For plots we will get the sum of squares. SSC, C denotes column, summation Tj square over Nj. Nj is the number of observation in each column minus C is equals to T. What is Tj? Tj is the number of total of each column, that is 21, 15, 24, 24. So we will get 21 square divided by 3, 15 square divided by 3, 24 square divided by 3, plus 24 divided square divided by 3 minus C. What is C? 84 square divided by 12. So we will, after calculation, we will get 18. Now for total, sum of square for total, we will take the formula summation xij square minus C. This means that we will take the squares of each observation. 6 square plus 4 square plus 8 square plus 6 square. We take the summation of all squares. That is 6 square plus 4 square plus and so on till 10 square plus 9 square. Minus C is 84 square divided by 12. So after square these values and minus the correction factor, we will get 36. Now we will draw the table for the all observations. Calculation, we will draw this table and we write the complete calculation right here for the F ratio. So we will compare the F ratio and F tabulated values in this table. So we get the complete result. So first of all, we will find degree of freedom. Degree of freedom, how we can find? Here is the number of rows are 3. 3 minus 1 will be 2. For the row, 3 minus 1 will be 2. Okay. For the column, there are 4 columns are there. So 4 minus 1 will be 3. And within error, we will find after the total. The total will be, here the number of observation are 12. So we will write here 12 minus 1 will be 11. So we will minus the values of rows and columns from the 11. Then we will get within error. 11 minus 2 minus 3. Then we will get 6. So likewise, we will find SS of error from from the same method. So we will write here SS for row. Here we have find the SS for row is 8. So we will write it here 8. And for column was 18. Then for total is 36. For SSE, we will minus 8 and 18 from 36. Then we will get SSE. That is will be 10. Okay. Then we will find mean sum of squares. For this, we will divide the sum of squares with the respective degree of freedom. So how we will find? 8 divided by 2 will be 4. 18 divided by 3 will be 6. Then 10 divided by 6 will be 1.6667. Then we will find the F ratios. 4 divided by, for F ratio, we divide the MSS divided by error. So 4 divided by 1.667. Then we will get 2.395. And likewise also 6 divided by 1.6667 divided will be equal to 3.593. Now we will find the tabulated values. For tabulated value, we will get the 2 mu's. 2 mu's will be 2 degree of freedom of rows with the degree of freedom of error, that is 6. Likewise for the column, we will get 3 and 6. And then we will find the value from the table which you have given after tabulated values. So I get it here from the table 5.14, 4.76. So from these values, we can compare the F ratios with the tabulated value and get the result. So here we will write the comparison. Yes, comparison. 2.395 is less than 5.14 for the row. And for column, that is plots, you can say 3.593 is less than 4.76. Here I have written the these values of F calculated and F tabulated from here. So we can say that F calculated is less than F tabulated, and F calculated is less than, for the column also, F tabulated. So our decision is that we accept H naught and reject null alternate hypothesis, that is there is no difference in fertilizers and plots. If you like my video, then subscribe and like and share to your friends. Thank you.